Okay. So horizontal compression and stretches happens to the function. Inside the function, you multiply by, let me use m, okay, for constant, mx. Now here's the interpretation. 2x, to my original input of x, I'm going to first multiply by m, and then second, I'm applying the function f, whatever that function f may be. Okay, in our case, it's square root of x, okay? Rooting the whatever input we put in. But there's a crucial difference that we're doing something to x before we apply the function f. Okay? So, let's see what happens. Here's an example. Let's see what happens. Y is equal to root of, let's say, 2x. Root of 2x. Now, we already know these root results. If you root of 0, you get 0. If you root of 1, you get 1. If you root of 4, you get 2, right? Now in here, if I want a root of 0, x has to be 0. If I want to root of 1, what does x have to be now in the 2x? If I want to root of 1, do you see that x has to be divided by 2 to get a root of 1? 2 times half is 1, right? If I want to root of 4, what does x have to be? X has to be 2. Do you see that compared to the original number, it's only half as much? Okay, look. Because I doubled x, the number I actually put into x has to be half as big. Since x is doubled, input of x is halved for the same output. Here's how you write the transformation mapping. X, y. X, because of the 2, it gets halved. And the y stays the same. So if you halve all the x inputs, we get the same y. That's the interpretation of this. So the important points are 0, 0, 1, 1, right? And it's 4, 2. So the inputs become 0, 0 still. This one is going to become half. This 4 is going to become 2 to get the same output of 1 and 2. Okay, look. Let me draw the original one first. 1, 1, 2, 3, 4, 2. This is the original, okay? The new one, look. I still want 1, but the 1 will happen at half. I still want 2, but the 2 will happen not at 4, but at 2. So look. I know this can be, some students go, hey, this looks similar to like vertically stretched. It looks like it's going up. But the better interpretation of this is that this point, horizontally, it's been shifted in, right? Not shifted, actually. It's been decreased by a factor. How much factor? Exactly half. So if you had to describe this as a horizontal change, what would you call it? Horizontal? Right, horizontal compression by factor of half. In general, look, if you have a K, or if you have an M like this, right? It's a horizontal compression by a factor of, here I would say it's half, but in general, it's a horizontal compression by factor of 1 over m. Because you times it by m, x has to be divided by m to get the same result from the function.